Let's start by going over the integrated rate law things, and let's make sure my answers on there are correct. So the first one, integrated rate laws. Question 1, you see there's 1 over, is linear, so that's going to be the second order. And then it wants a rate constant. The way to solve for this one is you're thinking in terms of this equation. The one that says y equals mx plus p. And it seems like a lot of people are trying to solve it by using this equation. All you need to know is that is the slope. And then you use the data to use the rise over run formula. That's what I was trying to figure out. And you just use the whole thing across the data. I should have truncated those. It's too many digits. And then 0 to 17. So you're just solving this. 1, 2, 3, 4, 5 minus that is too many digits though. So that should equal the slope. That should equal k. Hopefully it does. Let's try doing this. So 50.1. Did I get a negative value there? So that'll be negative. The numerator and the denominator come out negative here. If you flipped it around, if you took these over here and put these over here, they'd both be positive. Either way, you're going to come out with a positive.
How do you know when you use the rise over run versus just like the actual formula?
On the test, I'll phrase it exactly like this. So when it asks you to find k, do it with the slope method. Rise over run.
So if you're finding like a, like whenever 18, and you use that.
Yeah, but it's the same way with the other two. You're still just setting it equal to the slope. We'll do the other ones. So that was second order. And of course, the half-life for the second order is 1 over concentration A naught times K equals T to the 1/2. This, though, be sure to not mess this up. This is not in the 1 over column. The concentration for the second order and the concentration for the 0 order, when you're looking at the half-life, you end up looking at this column because this is the concentration. So you're looking for, this is initial concentration. So for this problem, A naught equals 0.00001. That's A naught. You see what I'm saying?
Could you just use the 1 over and do like the 1 meters?
Say again?
Could you just use the column all the way to the right instead of like the second one?
No. See that this is concentration. You can't see yet until that comes on. I'm not always sure it'll work. So you've got time here, and this graph down here is time versus concentration. Second graph is time versus natural log of the concentration. And then the third graph is time versus 1 over the concentration. We were focused on the 1 over concentration to do this, but realize when you get to half-life, the concentration you want, the initial concentration is actually here. That's the initial concentration. This is 1 over the initial concentration. This is natural log of the concentration. The formula for T1 half, this is telling you the initial concentration, not 1 over the initial concentration. Oh, I see what you're saying. Oh, no, that messed with my head. 1 over the initial concentration. So it would be, you're thinking like this. Right? If you separated these things, yeah, I guess that's what's in the column. 1 over concentration, so I guess you could.
I was going to do 1 over, like, times K.
How would you calculate this?
I would, like,
All right, well, I'll go through the calculation. This is how I do it. I guess you could be a little more creative. You might be able to use the third column if you think like that. But however you practice it, keep it that way. But 1 over 0. Didn't I write that down? I didn't
I
write
think
it
we
down.
just erased it.
Is it 5 zeros? 1, 2, 3, 4, 5.
I think it's 4.
Okay. 1, 2, 3, 4. It's 4 zeros. Put K here equals T to the 1/2, which is what you're looking for. And if I just went systematically first, I suppose I multiply these two things together first. Times 50.1 0.00501. So that's that. And then 1 but divided by 0.00501. Yeah, that's what I have for the answer. 1996. Also, look at the answer. You might have been able to solve this one without it. Do you remember what T to the 1/2 means? That's the time it takes for half of the initial shock concentration to be gone. You can look here and go, if you can see into it, time equals 0 to time equals 2,000 seconds. It does almost exactly go in half. This is 0.00001, and this is 0.0000049. So this is almost exactly half of the initial. So you might have guessed it was going to be around 2,000. Maybe that helps you think. But anyway, if you just plug in, did you see that? You okay with that? It's just a bit of algebra. You hate algebra, I can tell. So do you see how to do that?
Yeah. It's just confusing because it's different than how we did it in the textbook.
How did you do it in textbook?
Like, the OpenStack shows you how to do it, like, plugging in, directly to the formula, not using writing.
Directly into which one?
Like, if I was trying to solve for K, I would have just plugged all the values in and then solved it.
This wasn't K that I solved for over here.
No.
Oh,
I'm
you
like
mean
talking
this?
about, like, the first part and the second part. Like, it's just, like, the second part was how I would have solved it, but, like, solving for K up there is not how I thought you did. I think the textbook solves it.
Well, it's because this is the slope. This is what you see that's linear. This equation, if you graph it, is linear. And this 1 over AT is what's on the left axis, and T is what's on the bottom axis. So that's the slope. So it's very easy. We just set K equal to, that's not it. So you use rise over run to find the slope, and that equals K. How did the book do it? I thought I got that straight out of the book. Well, you see it now, right?
Yeah.
And all of these are like that. You're basically looking at slope for all of them. The slope of this line down here on the right, that equals K. Once it's graphed and it's linear, that equals K. The other two happen to be negative K, but it still works out exactly the same. How did the book have you do it? Okay, let's just do it the way I did it. All right, this one, number 4. So you see it's the natural log one that's linear. And of course that is first order. So the first order equation, you have natural log here. You're looking at the y equals mx b again. Negative kt. And I think you're making your life hard if you're trying to use this. I'm not even sure it really works. Because what is t going to be? Is it t of this or t of this anyway? B. And since that's the slope, negative k equals slope, and then you use the rise over run method. For the natural log one, it's 0.231 to negative 5.404. Remember what that said? 0.231 to 5.404. That's 5.404. Rise over run equals that, and I use my first value to this, so in the bottom it's near 0 to 1700. Are you seeing this? So again, you just find the slope. This time this is going to be negative, but this is negative kt. So once you multiply both sides by -1, you get positive anyway. 0.231.
For the time on the bottom, how did you get 17,000? I thought it was 75.
Oh, on a new one. Never mind. I thought I had it memorized. Okay. Sorry. This is why I make it complicated for y'all. Just stand up here and screw up constantly. 75. 75. Okay. Yes. 75 seconds. Okay. Is that right? So the bottom is going to be negative 75. And the top is here. 0.231. That's positive. A negative minus a negative is plus. Plus 5.404. 5.635. So on the top I get, on the bottom I get negative 75. It should come out to negative 5.635 divided by 75. I guess I could put a negative on there. So 0.751. Or is it 2? Does it round up to 2? It seems like it did. No, 751. I'm keeping too many significant figures though, since that's 2 point, there's nothing after the decimal. No, this is multiplication division, so 2 significant figures, 4, really I should just keep that. That equals negative k. This is what we just solved for. You multiply both sides by -1, you get k equals 0.075. I just fixed this one yesterday though. I had something else in there. This is the one I fixed. Is that what you got for this?
Yes, but I used the top equation to get it. I think like
Y'all are plugging all this in to solve for k?
Yeah.
There's no need to. If you can get the right answer that way, that's fine. It's not going to be wrong. But I just think that's way easier. And I thought that's the way the book showed you to do it. Is that the way they were telling you to do it at the study center or whatever?
Yeah, they're trying to do it that way, and then it doesn't match them up. Because like I just thought you can solve it.
You were able to get the right answer this way? Whichever one you like. I just think the
I wasn't.
rise over run is way easier. Huh?
I wasn't able to get the right answer.
Okay.
Like for the first.
That's it. And the way I solved the first one, just did it. If you're still struggling to do it, email me. Maybe we can meet. But it's probably just a matter of being meet with your algebra. You see how I go too fast and screw up constantly. It's just about being careful and meet. It's nice to be the instructor because I can screw up and not get it out. As long as I catch my screw ups. All right, so this was wrong. It was number 5 that I had the wrong answer in. I fixed it though, so 0.75. Okay, the units though. What order was this? Natural log. So this was first order. So there's a trick here with the units. You got 0.0751, 0.0751, 2 big digits, but you'd still know what the right answer is. It's the general formula is x equals order, and I'll give you this on the test too. X minus 1 moles, 1 minus x, and then it's always, you always have a test to the -1. If it's first order, this ends up being L to the 0, 1 minus 1, and then this ends up being mole to the 0. So these just drop off. And that should be the right answer. Did I do that part right? So it's the 0.075 with the just this as the unit is the correct answer. You see that? Maybe that's what you were doing. You were clicking on the one that had the wrong units.
No, I just like didn't get the actual answer.
I'm telling you, my way is so much more simple than using that ridiculous equation.
Okay.
So just set the rise over run formula equals k, and you should get the right answer. And again, if we want to do the half-life, which is number 6, we're going to need k from the previous problem. And again, you got to look at this first column for concentration equals 0. We're not looking at the 0.231. We're not looking at the -5.44. We're looking at this first column. The initial concentration is 1.26. 0, I guess. I wasn't careful with significant figures when I made these. But the half-life formula for this one is just this constant. Crap, what was K? 0.075. I'll do the significant figures right. 0.693. Oh, 9.2 for it's this one. If you wonder where the minutes come from, it's this unit. It's right here. It tells you what it is. This is time in minutes. Up here, this one says time in minutes. Oh. Did I have minutes there? Oh, yeah. Time and seconds for the first one. So that's why I have S here. That should be, yeah, just seconds. And this one, I did per minute, good. And 9.2 minutes. Okay, and the last one, that one's zero order, so we're looking at the first column. 0.0382. I'll write it on the board. 0.382 minus 0.144. So the numerator. So for this is number 7. We find the zero order. 0.382. That minus 144 over 0.75. 0.75 minutes. And of course, the equation we're talking about this time, you've got the y equals mx plus b there. Y equals mx plus b. The t is on the x-axis. Concentration is on the y-axis, and it's linear. So again, k equals the slope, and this is the rise over run formula for slope. It is negative. This will come out negative, and then the negatives will cancel. And I got for the numerator 0.238. And this will be negative 75. So negative k equals that divided by negative 75. Negative 3.17, but the negative is going to go away, so 3.17. Hopefully. Yeah, it rounds to 3.2. So k equals 3.2. L, x minus 1, mole, 1 minus x. Was this minutes or seconds? It was minutes, wasn't it? Yeah. So, we did 0 or 0 minus 1 is L to the negative 1. 1 minus 0 is mole to the 1. And then you're going to have minutes to the negative 1. Of course, you're not going to write that 1, so the unit should be negative 1, mole, minutes to the negative 1. So that's our units. And hopefully that's what I have on there. I have 3.2 times 10 to the negative 4. Did I do something wrong? Did I do something wrong? Is that incorrect? The times 10 to the negative 4. Is it? This minus this is not going to be huge. Divided by 75. I think that the 10 to the negative 4 is wrong. Check this right quick. There's us. 10 to the negative 4 wrong? It has to be. It's the last one. I think the 10 to the negative 4 is wrong. Did you get 10 to the negative 4? I got 3.2 for this. And that's the unit, so this should be wrong. So I got 10 to the negative 4.
I don't know about that now. I think the other six.
I don't think that 10 to the negative 4 should be it. So this minus this is still going to be 0.0 something. 0, 0 something. One more time. Here. It's 0.0382 minus 0.0144 is that divided by 75. So it should be 3.2. There's no mistake. It doesn't help practicing these when I make mistakes in them. That's number 8. I'm just going to fix it. If y'all discover that too, then maybe of course you can do it. So hopefully you can practice these cleanly. Let's see if I did the rate halfway correctly. Did you let's do this. Second order. Answer here was second order is this. Minus x. Over the second order, x minus 2 should be double. I think you have the units wrong there too. This is second order, right? One over second order, so that should be. No, it's lose. Well, -1. No, that's right. Okay. And here we got this. I'll check my answer key. Good. All right. This one is first order. The first order, let's go on. We got here 0.075. It's first order, it's just yeah.
This is all, but I want to go over the Arrhenius equation.
The which one?
The, I think Arrhenius.
Arrhenius, yeah.
Arrhenius.
I'll do that next.
Okay, is that going to come in test also?
Yeah.
Okay.
Everything that's on D2L will be on the test,
Okay.
just like it is on here.
Okay.
Hopefully without mistakes.
Okay.
We said this is first order. That means L to the x minus 1 mole to the 1 minus x, and this is minutes to -1. If it's first order, it's L to the 0, mole to the 0. So it should be, there's one of these that just has minutes. Right, so this needs to change. Right? natural law, it's first order. So that's 0, that's 0. So it should just be minutes for that. Oops. Number 5, all kinds of problems with it. This one, 9.2, right? This one, so 0 order. Zero order. Delta 1. Zero alter negative 1. All right, so the half-life for this last one. The K we got was 3.2. And the formula for the half-life for 0 order. Zero order. Crap, what did we get? 3.2. Is that what we got? My answer might be wrong here if I do 10 to the negative 4. 3.2. Initial concentration is 0.382. Divided by K, 2K. We have 3.2, so K is 3.2. All right, and I bet I'm off by order of magnitude here. Cleared, so 0.32. By 2 divided by 3.2. Over 5 and 9 is 6. Well, 0 order, right? 2, I bet I use.
Is it not 3.2 times 10 to the negative 4? Is it not 3.2?
I need to change it because I think that's wrong. That's what I was saying a minute ago. Did you guys do this one yet on your own?
I got 3.2 times 10 to the negative 4.
How did I not? What did I do wrong? Let's go back and look at that one. That's the one that just now changed. Okay, it is first order, right? So I got that much right. Negative K. First order, right? That's, no, it's 0 order. Okay, 0 order. I need to be using this. That's how I did it though, right? This one's 0 order, right? Question 8. Verify it, so I know I'm not going wrong. So I'm going to go 0.0382. Okay, so watch how I do this. .0382 minus 0.0144. That's the numerator, right? And then I'm going to divide it by negative 75, right? Divide by 75, negative. Oh, I see. It's out here. I missed it. Good Lord. So fix 5 again. I think I didn't even pass a test on this. It makes mistakes on me. So this is 3.2. Times 10 to the negative 4 to do the half-life. So now I'm going to go 0.0382 for the initial concentration, divided by 2, divided by 0.000. I suppose that's what I thought it would be. No, that's it. Yeah, the formula is, let's be real explicit because I think I got it wrong again. C1 half for 0 order equals concentration A naught 2 times K. All right. So in the top, 382. So I'm looking here, 0.0382 for the initial concentration. I've got 2, and my K was 3.2 times 10 to the negative 4. So when I put that in the calculator, it's 3 zeros, 0.00032. So I'm going to go 0.0382 divided by 2, and then I'm going to divide by 0.00032. Now I get 5.9. It depends on your rounding, but that's going to be the answer. 60.2. Did you see the 60.2? We got 5. Okay, I think that's okay. Let me go back and fix this one. Times 10 to the negative 4. Check my answer key as I go. This was first order, which means x minus 1 minus x. Minus 1, so there's no leader. 1 minus x. This is first order, so 1 minus x. So this one should just be permanent, right? Right? First order should just be permanent. This is first order, so that one I need to change the units. Right? I need to change the units on that one. That one should just be permanent. Which one do we have? First order, x minus 1 is 0, so there's no L. 1 minus 1 is 0, so there's no mole. that all I need to fix? Oh, yeah, this one's good. Whoever it is. If you're finding A or K or E's, anybody tried these before today? I fixed that one. The last question said find the rate constant. It should have said find frequency factor. I changed that. It gives you the rate constant and then it asks you to find the rate constant.
Yeah, there was like multiple labs. I assume that you wanted to solve for it.
That's frequency factor. Oh, this was the frequency factor. Find A or K. Find A. Determine the frequency. Yeah, this should have said rate constant. Okay, find frequency factor. That means A. Fix these. It should say the frequency factor. I was like, don't be sure to be practicing these. All you would have done is got confused. Wow. What am I doing? 2.9 times 10 to the 12. It's this one. What is the rate constant? The rate constant is this. What is the rate constant? That's fine. So that's the frequency factor. We'll find out when we try. We'll go through these. Oh. Constant. This one is 5K. I have to look through my spreadsheet. So this gives A, so this one is 5K. This one is 5K. Rate constant. So what is the frequency factor? This gives the rate constant 5K. So this is frequency factor. Given the frequency factor of the total on that number 1, that's number 4. Let's do this to be sure. KT. And we're given frequency factor 2.9 times 10 to the 12. We're given 157 degrees C. Gotta make that into K. 49.2 kilojoules per mole. T. We're finding, this is RT. 2.9 times 10 to 12. 8 equals 2. Okay, I think I've got this right. So let's solve this. This is number 4 on there. All right, two things to know. A is unitless. 157C needs to be turned into K. And the kilojoules needs to be turned into joules, so it matches this. So if that's kilojoules, 0.0492 joules per mole, we need that. And we need 273. I'm not doing the 0.15 because there's nothing after this. So 273.15, but really 273. 130K. Alright, so we're using A, using this for K. Should say T, that for the temperature. This is the activation energy. And this is R, I'll give you that constant. Alright. Let's see if I can do this. So you have everything up here, so let's solve for negative EA over RT. And that's going to be over 8.314 for R. And the temperature is 430. Temperature, yep, 430. Clear. 0.492 divided by 8.314 divided by 430. I'll say 1.367. 10 to the 5. On here, I think it's the EXP key. It's going to be EXP or it's E to the X. Yeah, on this one it's EXP, but you're either looking for a key that says EXP or it'll say E to the X. And what you've got on the screen is the X, and then you'll hit enter.
When you were, like, whatever calculation, just like not really here, but it was like a 492. Did you do like divided by 5, or did you do like?
Yeah, that's how I did it because it's easier to make that.
Okay.
I put the numerator in here and I said divided by 8.314, and then divided by the other thing, and it comes out the same.
Okay.
You could multiply them together and save that number, and then divide them. You
Does that
should,
still give the same number?
huh?
Does that still give the same number?
It will give the same number.
Okay.
Yeah, I had this in the calculator. thing, and then I went divide by 8.314, and then I said divide by 430. If I multiply these together, and then that number, I divided this number by it, it would come out the same. 376. Better double check it because that says 13. Let's double check it. Kilojoules. Oh, I did this wrong. If it's that many kilojoules, I move the decimal the wrong way. 1, 2, 3. Sorry. All right. If that's the kilojoules, the joules is going to be a much bigger number. So 49.2, 1, 2, 3, 49200. That's what I should do. That divided by 8.314. That, and then divided by what? 430. I've got 137. Instead of 13. I'm looking at my spreadsheet going, it's not coming out the same. 49200. Divided by 314 divided by 430. 13. Okay. It took me 3 times to get the same thing my spreadsheet showed. Let's do it one more time. 49200. 49200. Divided by 8.314. Right? 8.314. Now 430 divided by 430. Okay, 13.76. This was somehow I just got that off by a decimal constantly. And it's not times 10 to the 11. Okay, if you have that showing on your calculator, you hit that button or you hit that button, whichever one your calculator has. This one has EXP. EXP equals 0.032. Maybe it's the E key. E to the X is what I want to use then. 15.67. E to the X. All right, well, make sure you know how your calculator works. Oh, and it's negative. Right. there's a negative here, so that's negative, and it matters to have a negative there. This calculator has these in here, have the e to the x. Clear. Just one second. E to the x. And then negative 13.67. Close the parentheses. E to the x. Negative 13.67. Close the parentheses. Figure out this calculator. 6, 7. Again, e to the negative 13.67 has that. You guys double check it. Get a calculator and do negative that. EXP. On these calculators, before you put the number in, you hit clear. You go second. Clear. Can you even see that? Can you even see that? You go second, and then natural log, and then negative 13.67. Enter. So the screen shows you go inverse, and then you hit the key that says natural log. But just above it, you see the inverse. It says e to the x up there. So you go inverse, you hit this key, which gives you this, and then you'll see this on the screen with the cursor right there. And then you type in negative 13.67, and then hit enter. You might want to practice that with these. I struggle with it. You guys trying this? Make sure you get the same number I did. EXP in your spreadsheet. You guys get the same number I did? You want to put negative 13.67. That was the answer to this. And then e to that power. Did you figure it out?
Yeah, I got that.
Okay.
I got 13.7.
You got 13.7, but it came out very close to that, right? Did it come out exactly?
It came to negative 13.76.
Oh, really? You just rounded it and I did. Okay, now you're just going to take that and multiply it by a. So we just solved for all of that. Now you multiply by a, it should give us k. So multiply by 2.9 times 10 to the 12. 1.157 times 10 to the negative 6 times 2.9 times 10 to the 12. I'm going to go times 2.9, 3.36 times 10 to the 12 minus 6 is 10 to the 6. That's what you should get. Please. 3.36. I've got 2.9 times 10 to the 6. Is that A 2.9? I might have just done 1.1 there. Which would have given me 2.9. I did negative 13. 6. Oh. I transposed those numbers. That was 7, 6. What did you get for this? One of you said you got something different than me. .76. Negative 13.76. Is this what y'all got when you did this? 1.157?
When we calculated it, like we did the combined, we were talking about the 49,400 divided by, and we put in like parentheses the multiplication, and then we got like the difference.
Did you get that?
I'm getting like 3.1.
We better go through this. Because y'all are going to have to do this on the test. And I can barely do it standing in front of me. I got 1.057 once I corrected this. So that would have rounded to 1.1, and that's why I got 2.9. That's why I got 2.9, because this was 1.1. Rounded that to the exponential. So I ended up with 3.1. If that's supposed to be done, it's got to be 10 to 6. All right. All right, tell me again how you did this.
Okay, so we did we put it in the calculator just like that. Like
Okay.
it's 49,200, and then we divided, and then we did like open parentheses, and then we did like that multiplication to like keep it together.
Open parentheses, 49200, close parentheses. Do you say divide after that?
Yeah, like
Divide by, okay. And then open parentheses, 8.314, close parentheses.
we didn't close the parentheses, though. We kept it inside, so like the numbers stayed together.
All right, where's the backspace on here?
Like the way at the top. You read it?
Times. What is it, 430? without rounding,
Yeah, we,
it should be closer.
yeah.
How do you say previous feature? Oh, we had 13.
You, you're,
Okay,
and then
arrow
you
up.
can enter it.
Okay, it needs to be negative. I should have made that negative first.
Okay, so you put the positive.
Okay, you definitely need it to be negative. Come out completely negative. Okay, let me try again. All of you guys ought to be practicing this, because this is killing me. You do that, open parentheses, and then close parentheses, divide by, divide by, open parentheses, .314, and then times key, times, and then 430, and then close parentheses, and then hit this key to make it negative. That's important. This key. Should I put the negative first?
Kimberly may have something.
Let me try again.
Professor Emery, on the practice quiz, it's telling us to solve for A, not the rate constant.
I just changed it. I just fixed that problem. This is number 4.
Yeah.
The frequency factor is this. Temperature is this. The activation energy is this. Final rate constant. I just fixed it.
Okay.
The phrasing in all of these is wrong.
So
we need to
we
go.
were all over here like solving for K.
I know. I messed y'all up. You sat there trying to study. I messed you up. I know. All right, let me make sure I can do this if I expect you to do it on the test. Negative, open parentheses, 49200, close parentheses, divide by, open parentheses, 8.314 times 430, close parentheses, and I did put the negative on there, so I hit enter. That I did at the front. And you should see, and I guess we'll just leave all this here to solve this. And then you go inverse, and hit the natural log key, which shows either the x above it. Inverse, show that. Arrow up to that number to get it in the box. Guess you have to enter twice. And C 0.00000155. Y'all get that? Can you do it? You are going to have to do it on the test. I did it in a spreadsheet. Zero 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 1055 times 2.9. Yeah, it's the 3.1s. Comes out to 3.1 times 10 to the 6. You guys managed to solve this? Did you get 3.1 times 10 to the negative 6? Anybody unable to do this? You guys okay with this? You're going to have to do it on the test. You guys okay with this? You guys okay with this? Are you not getting the answer?
Is it positive 6 or negative 6?
Should be positive 6. This is 10 to the 12. And that answer is 10 to the negative 6. And you're multiplying them, so you should get 10 to the positive 6.
So the answer would be 3.1 times 10 to the 6.
Yeah.
Okay, so right here it says 2.9.
The answer is not 2.9, it's this one.
So that's 10 to the third.
Yeah. You get a fairly different answer depending on whether you round here. And I think we should round. All right. This is 3. This should be 3 significant figures. So really we should round that. But really what I should do is, and if you round it, I think you do get 2.9. We've got to figure out how we're doing this for the test. Negative. Open parentheses. Just put it in. Negative 13.8. Negative 13.8. So if you round it properly, you get this. And that times 2.9. You get 2.9 back. So I should not have put these on there so close to each other. This is, I'm sure, would have to be the right answer. Because if you round properly, that's what you get, 2.9. What I should have done, certainly from the 10 to the 6, you can see the right answer. Let me. I guess when I put this in here, I made sure the power of 10 was way off. Okay, so instead of this number, if you're rounding it to 3 significant figures, which is what you should get from there, you get negative 13.8. Try doing the exponential of the negative 13.8. See what you get. It's just inverse natural log negative 13.8. And that's when I get this. 0.0000106. No, 1016. So if you multiply this by 2.9, within 2 figures, you still get 2.9. That's how it ends up being 2.9. If you multiply this, that is, so we're multiplying, what's in space here? 2.9 times 10 to the 12 times 1.016 times 10 to the negative 6. This is basically multiplying by 1. You see that? So you just get the 2.9 back. So that's what I was doing. I was rounding correctly in the, it's called the mantissa. Is that what that's called? It's up in the exponential. Fancy word for it. I should be using that word. Crap. You guys see what I did? All right. If nothing else, if you got to the end and you have 3.1, at least the 10 to the 6 would show you. But I will start doing that because I did it in the spreadsheet. I rounded correctly. I rounded this correctly. 3 significant figures, 4 and 5. That is 3 after you do the addition over there. 157 plus 430. This probably should say 135. There's nothing after the decimal, nothing after the decimal, so that 430, I should have done that. Anyway.
When you read the question, finding PA, I think all the answers are right, but question 3 I couldn't get.
Okay, we'll do one of those next. I should do, let me make sure I fix the phrasing on all of these. This is my file. This one is given K, I fixed that and that one's phrased right. Number 2 is 1.5, 6.8. this one is solved for K. Let's see. Now that one's phrased correctly. First one was 6.1 and 261. So this one's solved for A. So that one's phrased correctly. Let's do the one where we solve for, I don't know, 20 minutes left. Which one did you ask about? You wanted to solve for E for A.
Yeah.
Solve for E.
Yeah. I did all of the other questions too, and like I got it.
Those all worked out for you?
Yeah.
Let's do one of these. Preview. So the find E of A is separate because it's a different formula. It's on the Arrhenius sheet. So now to solve for E of A, we're using this negative R where are we going? These are all phrased right. 27 degrees C. Two significant figures there. 2.1 times 10 to the negative 11. It's K. Rate. Okay, yeah, this is the 37 degrees C. This is the 2-point method. 8.5 times 10 to the 11. All right, so we'll just use these as labeled. I need natural log of K2 equals natural log of K1 is 2.1 times 10 to the 11. So that's the numerator. I'm sketching it out here. Now, 1 over T 2 1 over T2 and then 1 over T1. Here. All right, first thing I want is, well, let's do it with this. I need clear. So I'm going to put in 8.5. Is there a natural way to do the powers of 10? I see it. Times 10 to the, it's a key that says now in the box I'm going to put 10 to the 11. And I'm going to hit the natural log key. I did that wrong. You have to hit the natural log key first. 8.5 times 10 to the 11. All right, this one gives me 4.44. Natural log of 2.1, 10, 11, enter. Here. 1 divided by T2. Oh, I didn't even work this. So this one's 310K and 273. And this one is 273 plus 27, 300K. T2 is 310, so 1 divided by 310. That's K, clear, or 1 over K. T1 is 1 divided by 100. So now I'm going to set it up as 4.44 minus 26.07. K2 is K1. T2 we've got to do 8.314 negative using this formula, and that should solve for EA. Anybody get ahead of me? 4.44 minus 26.07 negative 21.63 0.0023 minus 0.0033. Enter. Oh, wait, that's right. What did I do? 0.00323 minus 0.00333. 0.000 negative. Lower than T3. T2 minus T1. Oh yes, they're both negative. Yeah, that's right. And we've got to multiply by negative 8.314. So it'll come out positive. Okay. 21.63 divided by 0.0001. I get positive 216,300 negative. This was from K1. That's K1. And I wanted to do this minus this. This was backwards. These were backwards. It's only the difference of a negative, but it's bugging me. So that will not be negative. Because we need to come out positive here. That's negative. This times negative 8.314. I get EA. Probably kept too many digits here. So that's 4. This was really 3. That one was 4. And that was 4. So this should be 3. So 1, 8, 0, 0, 0, 0, 0. Two, 1, 6, 300. 179, 9, 1, 179, 9, 1, 0, 0, 0, 0. What happened? But it's this, and it's a difference of rounding. Did you say it's the last one you couldn't come up with the right answer? Third. Did you get the right answer on this one? You got 108? What did I do wrong?
Maybe, is it supposed to be to the exponent of negative 11, not just 11?
Oh, is it? Yeah, which changes those odds a lot. I'll do the third one next. Is there time? There's not, but I will double check the third one and put a note on the 2L. I have to double check all of those at this point and give y'all better instructions on how to solve these. 8.5. Nope. Natural log. 8.5 is 10 to the negative 11. Natural log 2.1 10 to the negative 11. This is 2 and this is 1. So 2. Comes out negative though. This is 2. Just 37. So I've got these backwards too. The lower temperature is 1. Yes, I had those backwards too. So that takes this positive. 333 minus 323. And 23 minus 24. And that should come out. So 3 significant figures, 3 significant figures. 001. Times 8.314. Now I get. That's what I get now. You said you got 108.
Yeah.
What did I do wrong? 108 kilojoules.
Yeah, I got 108 or 103, but that's just joules, so I convert it.
So this is probably easier. I'm still doing something wrong. I've handicapped myself using spreadsheets all these years. I had no idea how bad it was. We're out of time. If we need to go over this more Monday, we can. There are a couple more things I was going to add to the test. We didn't get to much today.